Namaste, welcome to the AstroSolveX channel. In this video, we are going to show you our AstroSolveX project series number 1 on the rocket and a satellite tracker with using Python and Colab. Fine? Yeah. Here we go. First, let us understand what is the rocket and what is its trajectory. You might have seen in many movies, even the live rocket launches of SpaceX AstroSolveX, they use the software. Fine, they use the software, they program the trajectory of the rocket to plan a successful launch. So today we built that programming to show the trajectory of the rocket during the rocket launch. Fine. From our childhood, right from our childhood, we know the basic physics equations like F is equal to ma, F is equal to g, m1 m2 by r square, like many basic physics equations. With using these basic physics equations, we integrated some programming language called Python to show you the onboard dashboard for the live tracking of the rocket launch. Fine. So here you gonna please note that here I'm not going to write the code here because it takes much time. I already worked on this project for since 2 days, so this is the final product. I'm just gonna to run the code whether it is giving a correct output or not. That is only I'm going to show you. Rest would be we will discuss in the next series. And please note that the objective of this video is to showcase the possibilities and cutting edge technologies, upcoming technologies, feasibilities of AstroSolveX. As you know, this is our AstroSolveX company, certified company. We are planning to make the simulations for the advanced technologies in the coming days, like space elevators, satellite reliability, long reliability, and many more. Fine. And this is also personal to me because this certainly help me to build my strong portfolio for the USA universities for the higher studies. Got it? So here we go. See, this is the interface of Colab, Google Colab. You must have known this one. And yeah, here I wrote the language to draw the 2D rocket trajectory. Fine, using the values of initial velocity and the gravity and the theta angle degree of the rocket. Fine. So here we go. When I click on run, we got the product. This is the graph of the rocket trajectory on the 2D. Got it? Even we can change the values of initial velocity to 100, and also let us change the value of theta, and let us run the code. Fine. Now you can see the difference in the rocket trajectory graph. Got it? This is the value of height and this is the value of distance. What is the altitude and what is the distance of the rocket while it is going into the space when we launch. Okay, here you can see the 3D trajectory of the rocket. The same code I have applied, but little changes. We'll discuss that in the next video as well. So here we used the same values called velocity and here horizontal and vertical, because 3D must have the horizontal and vertical angles. So here if we can change even values of these theta, and we can see what would be the changes. Fine. just wait, let me make it to 60. Let us run the code. Fine. And here you can observe the difference in the rocket trajectory in the 3D motion, the 3D, fine, 3D simulation. Fine. And here this is the another code I have wrote for one video. Actually I will show you that later. Fine. And next, and now another interesting product would be, 1 second, this is running actually. Yeah, no worries. Here you can see the executing. Yeah, this is what you can see the animation here, how the rocket trajectory, fine, in the simulation. This is the rocket trajectory. Many of we think that rocket goes straight, but that is never happen. Got it? That never happens. The rocket certainly bends with some angle. Fine, that's based on many stuff. We'll not go now to discuss that, but this we always aware of this basic physics behind the rocket launch. Okay, and now let me show you. That is what the wonderful simulation, and let us run this code. Here we are installing the FFmpeg, and here let us run this code as well. Fine. Obviously it takes time. Yeah, fine. And as you observe in the code, in the shells of the different codes, there are some possibilities of what, debugs. So here I have saved the video. There the video is got saved, which you have seen here, this one. Yeah, that's it. I have saved for further reference. Got it? Fine. Yeah, now another wonderful outcome of the this project is tracking the real trajectory of the rocket on the dashboard. We have built it website as well. In that website you can check the altitude and the speed and complete details of the rocket. Here you go. I wrote the complete language. Fine. Yeah, this is a little complex here to understand, and it obviously takes to explain you, but let me show you directly what is the final product. Here you go. Yes guys, here you can see our final product, which is very exciting. Here you can see simulation is based on basic kinematic equations, which we have learned in our school days. Fine. So please observe this very carefully. Here this is the simulation time bar, right? When the time is at 44, the altitude is 0. Yeah, okay, the velocity, and still the pace is what? The rocket is at boost pace. Okay, when it is at velocity of 762, it is, what is the pace? It is at landed, and here you can see the trajectory, graph trajectory. This is little complex, and here you still doubting why the altitude is 0. This is little glitch here, but altitude certainly changes. Fine. And fine. Yeah, when the time is at 165, this is the velocity, landed pace, and this is the graph. Fine. Yeah, but hope you might have enjoyed, you might have clearly understood the earlier graphs. Fine, earlier graphs what I have shown you in the 3D as well, the 3D rocket trajectory motion of the graphs, which is very easy to understand what will be the motion of the rocket during its launch. Fine, so hope guys you enjoyed this one, and now let us now let us see the satellite in the same way. Fine, so this is what the rocket trajectory. Recently you might have heard some of the failures of the rockets. Worldwide, like SpaceX also in 2022 something, I'm not sure, but Falcon is failed due to lack of software. Maybe GNC, called the guidance navigation control systems, is lost. Fine, so when the software is very clear, uh, without any debugs or without any problems, then the rocket will certainly launch. Fine, the mission will be success. If there is a small mistakes, if there is a mistakes in the language, then certainly the complete mission will be failed. So that what happens in the aerospace industry, which is aerospace industry is known for the multidisciplinary and the complicated complex. Fine, so hope you loved this, and now let me show you the same thing for satellite as well. Fine, yeah, so here you see the satellite orbit. Actually this is not the satellite orbit, this is the earth. Okay, this is the of course the earth would be little sphere, it is not complete sphere, of course, but for our better understanding we just draw on the circle, and here you go. Yeah, this is what the wonderful. Yeah, so here we built it using ground station. Fine, and the satellite and the earth taking the reference, and we can see, and here you can see clearly I have imported HTML, which is very useful for the simulations. Got it? Fine, here you go. Here you can even observe the values of GMR. Fine, which are the constants, and there are initial conditions as well. Without the conditions, without writing all these things, it is highly impossible to get the final output. Fine, we'll discuss how to write the code betterly in the coming videos, but here you go. Yeah, the simulation video, where is that? Yeah, animation video. Yeah, here you go guys. See, you can understand even better in the little below here. Actually what happens here is, this is a satellite which is moving, which is orbiting. This is the earth and this is the ground station. When the satellite comes near to the ground station, then it is visible. Fine, when it is goes far, then it is not visible. Here you can observe even betterly. Yeah, just a second. Yeah, the same. Yeah, here you can see. Yes, this one, perfect. This one is, which is very clear. See, here the satellite is orbiting, right? This is the ground station which is moving along the earth. Fine, this circle is blue color circle is what the earth. Actually earth is rotating, but for our better understanding I made it static. Fine, without any motion. Fine, so here you can see easily when the altitude, this is the altitude, this is a speed is constant. You can see whether the satellite is visible. Here it is visible, and when it go for, it is not visible. even you can see the altitude, there is change in the altitude. Speed is what? Constant. Fine. This is what the how space organizations not only go everybody uses this basic, but obviously advance is there, but this is to understand the basic things. This is for school students, right? Yeah. Here this one I made for entire world. You can see, let's say, oh my goodness, it takes time. Here you can see it is executing the code, and it can it will give the final product. Before, meanwhile, here you can see the values geomer again, and the rotation with the omega. Fine. And there are some other physics equations, or we have integrated. We'll discuss it little later. Fine. Fine. So yeah, here you go. Just wait, it takes time. Obviously HTML is which is very essential for the animation here in the collab with the using Python. Got it. So here you can see the India location, because this is a new version of the world. You can see very clearly. Just wait a second, and meanwhile observe the values, map plots, and the earth rotation, longitude, latitudes. Fine. Got it. And the positions, initial conditions. Without giving conditions, we can't get the expected product. Got it. We can't get the expected product. So that is what exactly happens. Fine. Here you go. Oh my goodness, it is not weak internet. Yeah, just a second. Okay, meanwhile we'll see remaining as well. Yeah, this is also wonderful. I made the 3D animation of the earth. While earth is rotating, the satellite will also revolve around the earth. Fine. So the same code, but there are little changes. We'll discuss that in maybe probably next videos. But it taking time. So see, for getting the output, it taking time. For writing the entire code and showing you, it obviously takes consumes entire day, but I am not gonna to do that. Hope you happy with that. Yeah. So guys, yeah, we got this one. Wonderful. Yeah, wonderful. Yeah, see, this is the India. Got it. This is the satellite. Fine. Revolving around the earth, but this is the plot world map. Fine. This is the world map. How we can see on our GPS. Got it. This is another model, the same thing which we have seen above, but for better experience I made this. Fine. That's it. And here you go. This is another wonderful. At the end, we'll definitely like the how we build the real time dashboard for satellite tracking as well. Fine. See, sometimes the AI gives some warnings here, because it is inbuilt with Gemini, right? Fine. So that's why sometimes it gives some warning. Even Gemini helps you to write better. If there is any debugs or the errors, then it can definitely explain you the debugs and how to resolve it, how to fix it. Even sometimes it can write the better code for you, but that sometime works, sometime not, but you have to take care of that. Fine. You have to check that. Fine. Okay guys, fine. Yeah, let us move next I'll show you that once it's done. Yeah, here you go. This is another 3D real-time satellite tracking. Fine. Yeah, once yeah, this is actually you'll definitely enjoy this. Look at here. Actually, I hope you have seen this earlier. The same thing which have again tried. Fine. Sometimes one code won't work out. So again I have to write. Again I have to check the possibilities outcome. Right. So yeah, this is what. And here the another crazy thing which I have tried is not this time in this shell I wrote the code for multiple satellites. Right, there are the 3 satellites. Here you can easily see satellite 1 2 3 and the ground station. And here you go, see, here you go, the rotation, evaluation fine, orbiting of the satellites, we can say. Fine. See, here you can clearly observe the different satellites are moving with a different speed, with a different altitude, with a different velocities. Fine. Yeah, so this obviously happens, right? All satellite never move with the same values, everything, every same values, each same values, then that's not possible, right? Sometimes it collapse. Even I too don't know, but which is not applied maybe. Yeah, so that is what the wonderful animation which I have seen just now. And now the wonderful and the end of this session is, let me show you the real-time tracking of the satellites. Fine. Here you have to wait maybe 1-2 minutes. Fine. Either I will remove this waiting period once it done. Fine. So let me be on my way. Yeah, actually here you can see, after installing the PYTHON+COLAB+NGROK, Streamlit PYTHON+COLAB+NGROK, that gives you one real-time token. Fine. That token you have to use to see the dashboard. Fine. Let me explain that at the end what is that exactly, but before that let us take the code which we have used here for this rocket one. Just wait, always it takes time. Yeah, here you can see yeah, just this one only. Yeah, this is a token. Got it? This is the token. So let us do one thing. Instead of that, instead of using this, let me do another crazy thing. Yeah, before that let me remove this one to avoid the errors. Actually we can use the same code for both, even multiple, but that takes time, man. That takes time, and to avoid confusion, errors, I got errors, so that's why I have compromised. So yeah, compromise in the sense, sometimes we have to see the use the multiple platforms, paths, right? Yeah, yeah, this is our final product, guys. I worked for much time for this final product, so please understand this, which is, don't worry, which is very easy to understand. Here you can see the simulation time bar, and here altitude, speed, and the status, which is the satellite is visible from the ground station or not. Fine. When the simulation time is at 201, the altitude would be 404.02, and this is the speed is the constant here, and the visibility, the status is, it is visibility. Fine. And here you can see the where the satellites are. Fine. And we can even zoom it, and we can see a graph like this for better view. Fine. Yeah. And when the simulation time is at 486, the altitude change it 409, and the speed is constant, but still the status is visible. Got it? When it is 1003, the altitude changed, it is still visible. Yeah, it is now, it is not visible at 910, it is not visible, the altitude is 418. Fine. 0.2 something. So this is what the real time monitoring, real time updates of the satellite from the ground station. I have seen this one in NRIC Hyderabad. Fine. While on the camp, during camp, I have seen this one, and which is very exciting thing this is, to see, to witness this one in live. So this is what the basic which we have to understand as the school grade students. We must understand this one, which is very essential for the 21st century. Fine. So that's it, guys. In the next video, certainly I will explain you how all these things worked. Fine. And how to write the code using Python, Colab, and sometimes MATLAB as well, and sometimes Simlink as well. I'm still mastering them. It takes time. Fine. Hopefully I'll back with another video. Got it? Also with the series 2. So till then, signing off, your Nikhil. Guys, please comment, share, and subscribe for coming videos.